Greetings grade 12s and welcome to Ubuntu Academy, lessons that empower. We are back again in preparation of the June examinations, especially for the Gauteng learners who will be writing paper 2 physical sciences on the 19th of June. So today we are continuing with organic molecules. In the previous video, we looked at the nomenclature of organic molecules. So today we are looking at the physical properties of organic molecules. Okay, remember the scope that we are following is the one that was provided. I did indicate in the previous video that this section will be divided into 3 questions. Okay, remember the previous video we looked at the first part of these 3 questions, and that is likely going to be in your question 2 after the multiple choice. So now today we are going to be looking at what is likely going to be in question 3. Okay, what is it that we should expect in question 3? Of course, as we do in all our videos, we look at the definitions first. Which definitions you should make sure that you study. The first one is the boiling point, melting point, and vapor pressure. These are the most common definitions that you are likely going to come across in question 3. Of course, sometimes there would be a definition that we already mentioned in the previous video, which can be carried into this question, but we've already dealt with it. So you should study all the definitions anyway, because we don't negotiate when it comes to definitions. We get all the marks in terms of our exam. Okay, now next is what is at the center of this particular section: the different types of intermolecular forces. You should be able to know those intermolecular forces and be able to rank them according to their strength. You should know which intermolecular forces are the weakest, and those are the London forces, followed by the dipole forces, and lastly we have the strongest of the 3 types of intermolecular forces, and those are the hydrogen bonds. Okay, this is a continuation from your grade 11. So you should know the types of intermolecular forces and which ones are stronger than the others, and so that you can be able to compare different molecules, especially in terms of their physical properties, such as boiling point and melting point. All right, now in this slide I want us to look at the homologous series and which intermolecular forces are present in those homologous series. Okay, firstly, we have a table here. We are looking at the different homologous series. As we can see, in the hydrocarbons, these are what we call the hydrocarbons. Okay, my pen is not doing what it should do. These are the hydrocarbons. Okay, in the hydrocarbons, the only type of intermolecular forces present are the London forces. Now I need to clarify something about the London forces. These London forces are actually present in all the homologous series. Okay, in all of them we do find London forces in ketones, aldehydes, haloalkanes, esters, and so London forces are not only present in the hydrocarbons. No, they are present in all the types of homologous series. However, they are the only type of intermolecular forces that are present in the hydrocarbons. Unlike in the ketones, aldehydes, and haloalkanes, in these homologous series, you get the dipole forces plus the London forces. Okay, let me write this correctly. So you find that there are the London forces plus the dipole forces. So basically the London forces are everywhere, but because the hydrocarbons do not necessarily have any other types of atoms except hydrogen and carbons, they don't have other types of intermolecular forces. They only have the London forces, whereas the ketones will have dipole and London forces. We focus mostly on the dipole because they are stronger than the London forces, as we shown you in the previous slide. Okay, so even here the same thing happens. We find that we have hydrogen bond plus the London forces. So the London forces are there together with the hydrogen bond. Okay, so what in a nutshell, what I'm saying is that alkanes, alkenes, and alkynes only have London forces, whereas ketones, aldehydes, haloalkanes, and esters have London forces and dipole-dipole. Then alcohols and carboxylic acids have London forces and hydrogen bond. Okay, we don't really talk much about the London forces in the ketones and aldehyde and so on, because they are weaker than the other type of intermolecular forces that are there. I've also summarized this in this line here, where I indicate that you should know that let me just quickly change the color of the pen. You should know that the London forces are found in all the homologous series. Okay, they are the only forces that are present in the hydrocarbons being alkanes, alkenes, and alkynes. However, they coexist with other types of forces in the other remaining homologous series, and that would be your column 2 and column 2 on the table above. All right. Now, why are we learning these intermolecular forces? Remember, this section is about the physical properties of organic molecules. Physical properties are your boiling point, melting point, and the vapor pressure. Okay, you would have learned in grade 10 what is a physical change. Physical change is when you have the substance changing from one phase to another phase, usually changing from liquid to solid, or from solid to liquid, or from liquid to gas, and so on. That's a physical change. Okay, hence we are learning physical properties. Now, what is it that determines the boiling point of these molecules? What is it that determines the melting point, and so on and so on? So what we should know is that when you want to boil, for instance, let's talk about boiling a substance. You are actually separating, you are trying to separate the molecules. You're not breaking them apart. You are separating them because they're held together by a force, and that is the intermolecular force, which exists between the molecules. That's why it's called an intermolecular force, because it is in between the molecules. It's holding them together. Now, what you then need to know is that you need energy to separate or to overcome those intermolecular forces. So those intermolecular forces that are stronger usually need more energy to be overcome. Remember, we do not break intermolecular forces. This is a force of attraction that exists between two molecules. You can't break a force of attraction. You overcome it. Though, please, it's a very common mistake that we see a lot where learners say the intermolecular forces will be broken, especially with the hydrogen bond, because they see the word bond and then we think that we can break that bond. No, hydrogen bond is a type of intermolecular force. It does not get broken, it gets overcome. So you overcome those intermolecular forces. But when they are strong, hence I indicated here, stronger intermolecular forces will require more energy. Okay, why do we need to overcome the intermolecular forces? Is so that boiling can take place. If you remember, in your grade 10, you used to draw okay, made a mistake here. Okay, you used to draw for instance, you used to draw these for solids, and then you also draw for, let's say, gas. I'm not going to put liquid there. Okay, for solids, you say the particles are packed closer to each other, whereas for gas they are far apart. And the reason why they are far apart is because the intermolecular forces, the forces between these molecules, are weaker in the gases and they are much stronger in the solid. Okay, so in order to separate these molecules in a solid, you have to overcome the intermolecular forces which exist between the solid particles. This is what actually happens in boiling and melting and so on. All right, so you need to know that the intermolecular forces will require a lot of energy if they are strong for you to overcome them. Then molecules with stronger intermolecular forces will have higher boiling point, higher melting point, and lower vapor pressure. There is that inverse relationship that exists between boiling point and vapor pressure. Generally, molecules with higher boiling point will have lower vapor pressure and vice versa. Okay, so if you have molecules that have strong intermolecular forces, you are going to need a lot of energy to overcome those intermolecular forces, and therefore the boiling point will be high, or the melting point will be high, or the vapor pressure will be low. Okay. Now, let's look at what is likely going to be assessed now that we understand which type of intermolecular forces are found in which homologous series. Okay, just remember, with regards to the hydrocarbons and those other homologous series, the hydrocarbons only have London forces, whereas all the other homologous series have London forces and another type of intermolecular force. Okay, now if you were to be given molecules that have the same type of intermolecular forces, it's quite difficult sometimes for learners to understand how do we compare molecules that have the same type of intermolecular force. They can be compared, and you should learn how to compare them, right? If you have, it's usually going to be molecules in the same homologous series. Most of the time, you'll find that you're comparing two molecules that belong to the homologous series, such as alkanes. Maybe you're comparing a hexane and a propane. They belong to the same homologous series, therefore they have the same type of intermolecular forces. Okay, what you do there when they have the same intermolecular force, compare the chain length. Okay, check whether the length of the chain is the same. Also compare the branching. If there is branching in the other one, for instance, there's a substituent in one chain and the other one does not have a substituent. Okay, generally what happens is that the longer chains have more points of contact for intermolecular forces. A longer chain will have more points of contact. Sometimes we say it has a larger surface area, therefore there are more points of contact for this same type of intermolecular force. And because of that, it's usually the London forces that we're focusing on here. Because of the length of the chain, there would be more points of contact. And when there are more points of contact, it means there are more of these intermolecular forces. There are more intermolecular forces in the longer chain than in the shorter chain. Of course, if you have more intermolecular forces, even though they are the same in terms of strength, in the other one they are more, you are going to need more energy to overcome the intermolecular forces in the longer chains, because they are more. Even though they are the same in terms of strength, they are more, therefore they will require more energy. This happens when you are dealing with the same type of intermolecular forces. All right, usually that would be happening in the same type of homologous series. Hence, we then say the longer chain will have a higher boiling point or melting point and a lower vapor pressure. Okay, we get the high boiling point and the high melting point from the strength of the intermolecular forces. Okay, how do we compare strength of the same type of intermolecular forces? We look at the chain length to see whether this one has a larger surface area. If you have a larger surface area, there are more points of contact, therefore there would be more of this same type of intermolecular forces, which will then require more energy than when you have less of them. Okay, this is how you compare molecules that have the same type of intermolecular forces. Now, there's a special type of comparison that actually exists between the carboxylic acids and the acids. Let's say, for instance, you're dealing with propanoic acid, okay, together with propanol. Both of them have hydrogen bonds. But if you remember, if you saw in the previous slide, here what we indicated is that in the alcohols, here's an alcohol, here's a carboxylic acid. In the alcohols, there's only one site for the hydrogen bond, whereas in the carboxylic acid, there are two sites. Therefore, the propanoic acid is likely going to have a higher boiling point than the propanol, because there are two hydrogen bonds in the propanoic acid and there's only one hydrogen bond in the alcohol, which is a propanol in this case. The chain length will be the same there, but because of the two sides of hydrogen bonding in the carboxylic acid, it will have stronger intermolecular forces and therefore have a higher boiling point, even though they have the same type of intermolecular forces. Right, now what happens when you have molecules or compounds with different intermolecular forces? This one is a bit easier to compare because you know that the different types of intermolecular forces also have different strength. So this is why it is important to know in which homologous series do I find this type of intermolecular forces, and we've dealt with that in the previous slide. Okay, In this one, what you do, you compare the strength of the types of intermolecular forces that exist. Remember, please remember, all of them have London forces, okay? So when you write this down, let's say, for instance, you need to write, it happens a lot where you have these 4 marks types of questions where they ask you, explain why the boiling point of molecule B differs from the boiling point of molecule A or C. What you do, you indicate that this is the similarities between them and this is the differences between them. If you are, for instance, dealing, like earlier on, we spoke about the alcohol and let's say we are dealing with an alcohol and an alkane. Alcohols have hydrogen bonds, alkanes only have London forces. Okay, so you'd say that the alcohol has London forces and hydrogen bond, whereas the alkane only has London forces, and therefore the strength of the intermolecular forces will differ. Those different strengths will lead to a difference also in the boiling point and melting point. So the compounds with stronger intermolecular forces will require more energy. This one you have to mention. You don't just jump from saying this one has a London force and the other one has hydrogen bond, therefore this one will have a higher boiling point. No, you have to mention the energy required to overcome the type of intermolecular forces which you've already identified. You have to mention them. You have to mention the type of intermolecular forces that exist between these molecules and the type of intermolecular forces that exist in the other molecules, and then also indicate that this type of intermolecular force is stronger than the other one, therefore it will require more energy to be overcome, and hence will have a higher boiling point or will have a lower boiling point. And that's exactly on bullet point number 3. The compounds with stronger intermolecular forces will have higher boiling point or higher melting point and lower vapor pressure. All right, so this is some of the things that you have to really pay a lot of attention on. But everything is centered around understanding which type of intermolecular forces are found in the compound that you are studying. All right, if for instance you are dealing with let's do an example before we go to the wrapping up in terms of the exam tips. Okay, let us say you are dealing with propane. We did mention this. I just want to talk about this just now. And propanol. Okay, we know that because propane belongs to the alkanes and propanol belongs to alcohols, these are molecules that belong to 2 different homologous series. For that reason, in the propane you will find London forces only. Okay, so here we'll find London forces, and this side will find both London forces together plus hydrogen bond. Okay, hydrogen bond. So how then do you compare? You would know that if this one only has London forces, but this one has London forces and hydrogen bonds, these ones are stronger. Okay, these intermolecular forces this side are stronger, and these ones are weaker. The stronger ones, what happens? The stronger ones will require more energy. Okay, so I'm not going to write all of this down. These ones will require more energy to overcome these strong intermolecular forces, and this one will require less energy to overcome the weaker intermolecular forces. That is why the propanol will therefore have a higher boiling point, okay, compared to the propane, where you are going to have a lower boiling point. This is just in a nutshell how you compare 2 different compounds that have different types of intermolecular forces. However, if you were to compare in the previous slide, I should have done this example in the previous slide. If you're going to compare propane and hexane, because propane and hexane are not do not have different. Okay, let's deal with this. Okay, if you're dealing with hexane and propane, here's hexane here. Hexane, both of them have the same type of intermolecular forces. They both have London forces only. Both of them only have London forces. Now, you cannot talk about the type of intermolecular forces that exist between the two as the difference maker. No, it doesn't make a difference. The difference is made by the chain length, okay? Hexane has a longer chain, okay? If you have a longer chain, the longer chain will result in a larger surface area. A larger surface area. I'm not going to write the whole word. SA, there is not South Africa, it's surface area. Okay, the larger surface area will lead to more points of contact, and if you have more points of contact, it means there will be more of these London forces than here. You still have the same London forces, but this side there will be more of them. There will be more of these London forces, and here we are going to have less. If you have less of these London forces, therefore you need less energy as well to overcome these intermolecular forces, because they are less anyway, and here you're going to need more energy to overcome those intermolecular forces. So this is in a nutshell how you compare the different types of chains or the different types of homologous series, if you are dealing with different homologous series, or the different types of compounds. If the compounds belong to the same homologous series, it means they have the same intermolecular forces, and therefore you have to check other things as well as branching. Branching is also another factor. A molecule that has a branch, when compared to a straight chain, the straight chain usually has a higher boiling point or higher melting point. The intermolecular forces there are stronger. That is because chances are the surface area in the straight chain is larger than the one with the branches. And also because of the branches, the molecules are further apart as compared to a straight chain where the molecules are closer together, and therefore the intermolecular forces become stronger, even if they are the same, but they become stronger because also of the distance between the two molecules. Okay. Now, in the exam, you should be able to identify the dependent variables. Sometimes you get a table, sometimes you get a graph. You must be able to tell which variables depend on which. The boiling point, melting point, and vapor pressure are what we say are the dependent variables. They depend on something else. Now, the independent variables are the ones that dictate the boiling point, the melting point, and the vapor pressure, okay? So the chain length will determine the melting point or the boiling point or anything above there. Those are the dependent variables. They depend on the chain length. If you're comparing chain length, it's because you're looking at the same homologous series, okay? And then also the other independent variable is the surface area. The surface area would be when you are dealing with the same homologous series. Also pay attention to the branching, which can also affect the surface area, okay? And also look at the type of intermolecular forces. This is when you are dealing with different homologous series. That would be the strength of the intermolecular forces. You compare the strength of the intermolecular forces, because in different homologous series you are likely going to find different types of intermolecular forces. All right. Now, this has been Buto Academy, lessons that empower. I hope you feel empowered and you are going to continue studying, and we meet again in another lesson. Hopefully we'll be able to finish the organic chemistry part before going into the exam.